Okay, we have yet another proof method. I'm sorry, there's a lot happening, but this one we've done before, proof by cases. Like lecture mentioned, this is similar to the thinking we used in oralims in natural deduction, right? If we are told that the statement P or Q is true, and P leads us to some other conclusion, we call it R on the natural deduction worksheet, and Q leads us to the same conclusion R, then no matter what R is true, it works. That is the same idea we're going to go with in cases, that if each case leads down to what we want, then what we want works. And what is what we want? Well, right now it's this gross looking thing. There's a lot happening here, but if you were a little confused, min is like a computer function. If you send in two numbers, it's gonna spit out the smallest. And then you could put that as an input to a second function. So the smallest of this will show up, and then we'll take the minimum between A and the smallest of this. That's how that works. And this by itself, if I don't think of proof by cases, I just don't know what to do with this statement. I can't simplify, I can't, how do we start? But if we knew that, say, B was less than C, then we could start simplifying, that this would be B, and we could start trying to work through this. So that's kind of a hint we might use if they didn't tell us to use proof by cases. We would look at this and go, well, if I knew this piece of information, that would be helpful. And so we're going to give it to ourselves and just split this up into cases. Case 1, A is the smallest. It is less than B and C. Now I don't even have to know whether B is less than C or whether B is greater than C. I could break this into farther cases and do my proof that way, but it would mean a lot of cases and I just don't need them, so I'm not going to. So this is our first case. And how does this information help us? Well, if I want the minimum of A, comma, the minimum of BC, like this, I don't know whether B or C are smaller, but I know that A is smaller than whatever this minimum is. And so this is going to equal A. And then for the right-hand side, if I'm taking the result of this statement, I can simplify a little bit. The minimum of A and B gives me A. We're left with minimum AC, which again equals A. And so check mark, they're equal. Both sides are equal. Okay, what about case 2? What other case might I need? Well, I need B is the smallest. And then I'll do very similar looking work and get that both sides equal B. And case 3 is that C is the smallest, same deal, and it'll work out. I'm not going to run through all the steps because I don't think you want to watch that, but I'm going to show you this is the official instructor solution that got written out a couple semesters ago. So if you want to see how we would describe this in a proof, feel free to pause the slide, read through it. It's pretty nifty. Okay, that's it for this one. You're almost done with lecture 5.